Alright, so in this video we're going to go ahead and continue talking about trigonometric or inverse trigonometric functions. And so here we have an example. And so we're asked to evaluate sine of 2 cosine inverse of 3 over 5. And so much like the example that we've already done, we're going to kind of follow the same process here. And that is that I'm going to go ahead and say that this right here is our theta. And so there's theta, and so I'm going to go and write this off to the side. So theta is equal to, let's see, cosine inverse of 3 over 5. And again, just verify that this 3 over 5 does fit the domain, and it definitely does. 3 over 5 is in between -1 and 1. And so what we have to do now is just rewrite this thing. So we're going to go ahead and use our definition. So we're going to say cosine of theta is equal to 3 over, whoa, give me 1 second. Okay, so sorry about that. Having a little technical difficulties here, but that's fine. So again, we set that cosine of theta is equal to 3 over 5. That's the same thing as saying theta is equal to cosine inverse of 3 over 5. Again, 3 over 5 is not on our unit circle, so we're going to go ahead and sketch this. Now, remember that cosine inverse is valid in quadrants 1 and 2. And because cosine here is positive, that tells us that we are in quadrant 1. So if I go ahead and sketch quadrant 1, it'll look something like this. Okay, and then again, I'm going to go ahead and create some angle here. We call that theta, and I have some point here on the graph, and again I'm going to make a right triangle. Now just keep in mind that our definition for cosine is our x over r, and so here x would be 3, that's going to be this horizontal distance here, and then r would be 5. So again, the same thing that we did in the previous video is we have to find our y value. Well, we use the Pythagorean theorem to do that, and so we can get, let's see, 3 squared plus y squared equals 5 squared. And again, we're going to get 9 plus, let's see, y squared equals 25. Subtracting 9 on both sides is going to give us y squared equals 16. And then again, if we take the square root, we're going to get y equals plus or minus 4. But we're going to go ahead and keep it positive since we are in quadrant 1. And so we have y. So I could write here that y is equal to 4. So if I come back to my problem here, let me change my color. We technically now have to find sine of 2, and then we have our theta that we substituted for. And so we got to ask ourselves, well, what is sine of 2 theta? Now this right here is a double angle identity. And so just remember from your double angle identity formulas that this is equal to 2 times sine of theta times cosine of theta. So that's really what we have to find. And again, theta is sitting for us over here. So we're going to use this triangle and use definitions of sine and cosine that we've learned in the past to kind of fill in what sine of theta and cosine of theta are. And so here we're going to have, let's see, 2. Now just remember that sine, I'm going to go ahead and write their definitions here. So just remember that sine is your y over r. And again, cosine of theta is your x over r. And so what we're going to go ahead and do is now just plug in what they are. And so this is going to equal, let's see, 2. And then y over r, well, y was 4. And r is 5. Let's see, x, well, x was given. That was a 3 over 5. And if we just multiply straight across, let's see, 2 times 4 is 8. 8 times 3, well, that's just 24. And then the denominators, again, this is really 2 over 1. So 1 times 5 is just 25. And so sine of 2 theta, or sine of 2 cosine inverse 3 over 5, is really just 24 over 25. And there's our final answer.